Okay, we know that all points on a circle, or the geometric definition of a circle, is all points which are equidistant from a given point. So suppose we have a given point hk, and we have a distance in mind r, then we have our circle is all points which have distance r from the point hk. And so we can write this geometric statement as r is the distance from any point on this circle x, y to the point hk. And using the distance formula, that says that r is the square root of x minus h squared plus y minus k squared. Now if we square both sides of this formula, we get x minus h squared plus y minus k squared equals r squared. And if you cast your mind back to a previous lecture where we discussed solving equations, we might get some new solutions to an equation by squaring both sides. So we have to be careful. Some of the solutions of this equation may not be solutions of the previous equation. However, in this case they are, because r is positive, and the only solutions to this equation are either of this form, or r equals negative the square root of the left-hand side here. But since r is a positive number, we have nothing of this form, and so all of the solutions are solutions to this equation. So these are equivalent equations. So therefore, every point on this circle fits into this equation. And so this is the general equation of a circle with center hk and radius r. In particular, if h and k are the center of the circle is at 0, 0, the equation looks like this. X squared plus y squared equals r squared. How do we use this? Well, suppose we're given an equation that looks like this, then we can transform it to the equation of a circle and graph it pretty easily. And we can do this by using a technique that we looked at before by completing the square here. So we're going to complete the square for x, the x part and the y part here. So we have x squared plus 2x plus half of the middle term squared here, which is 1 squared, plus y squared plus 9y plus half of 9 squared. So that's 9 squared over 2 squared, which is 9 squared over 4, plus the 3 we already had there equals, and now we've added 1 plus 9 squared over 4, 81 over 4, to the left-hand side, so we should add that to the right-hand side to preserve this equation and its properties. Now this should be a square if we've completed the square properly. It should be x plus 1 squared plus y plus half the middle term, which is 9 over 2 squared, plus 3 equals 1 plus 81 over 4. That's 85 over 4. And now I'm going to subtract this 3 from both sides, and I get x plus 1 squared plus y plus 9 over 2 squared equals 85 over 4 minus 3. And that's equal to 85 over 4 minus 12 over 4, which is equal to 73 over 4. Now, this is the equation of a circle with center, so it's x plus 1 squared, so that's of the form x minus h squared, plus y plus 9 over 2 squared, and that should be of the form y minus k squared equals 73 over 4. And this is a circle with center minus 1. This should be x minus h, so it's minus minus 1. And this is y minus k, so my k here is minus 9 over 2. And the radius, well, this is r squared, so my radius is the square root of 73 over 4. And you can check on your calculator. That's approximately 4.272. So the graph of this circle looks like this. It centers at -1, -9 over 2. So this is -1, -2, -3, -4, -5. And so its center is way down here. And its radius is approximately 4.272. So from here to here is 4.5, so it falls a little short of the x-axis there, its highest point. And yeah, it's a circle with that center and that radius. So it roughly looks like that. Pardon me, looks more like that. You should try this next example and see what you get, and then have a look at the solution on the next video.